So we've seen that there are several types of supernovae. We have type 1A, which is a white dwarf star exploding, type 1B, type 1C. These are types of supernovae in which the outer layers of a massive star have been pushed away and they blow up. And the actual type 2 supernova, which is just a generic massive star blowing up. And then we've seen a couple of stars, and now we've actually seen a couple more since the 1993 one. So there's another type of supernova that is similar to supernova 1987A that starts off as a type 2 supernova and then ends up as a type 1 supernova. Some astronomers call this a type 1-2 supernova. Though that's not really an official designation. But that is what a number of people call these type of supernovae. They're these hybrid types. And so, again, now we're up to 5 supernova types. And Walter Baade had suggested there might be 5 or 6 different types. So let's look more at type 1-2 supernovae by looking at the nearest one, supernova 1987A. And so the Hubble telescope, looking at it after the first servicing mission, got a clearer view and saw that these outer rings and then an inner ring, and the cloud of gas in the middle is gradually expanding as time passes. That's the actual supernova. Those other rings that are out there were given off by the star before, the other rings were given off by a star before it blew up. And so what we think happened is that the inner ring was actually given off first, and then we have the outer ring. And so what happens is that when it was a red giant, it expelled gas and maybe a couple of different episodes. And as it expelled gas, then you got those rings there. They would have been there anyway, and then the cloud in the middle is from the supernova explosion. It's glowing in part because it's hot, but also because it's lit up by radioactive decay. You produce all the possible elements on the periodic table in the supernova, and you're producing a lot of radioactive elements which are decaying. And so that's still releasing energy long after the original. And so here we have kind of a view of the supernova exploding in the middle with the rings of previous exploding gas. Now, an interesting thing happened, and that is that in 1987, but about 10 years later, in that ring, as the cloud of gas in the middle is gradually expanding, a little bright spot developed. And over time, you got more and more bright spots developing in that ring. And so if you look here, over time, as that cloud in the middle is expanding, more and more bright spots in the ring are developing. What's going on with that? Well, what's happening is that that cloud in the middle it's a cloud. It doesn't really have a sharp edge. So there's pieces of gas that are much faster than other pieces that are moving out there, and they're starting to run into that existing ring. When they hit it, they cause it to glow or release energy. And this is interesting because that means that now we have evidence that sometime after the supernova, you have this secondary effect if it's a type of supernova similar to this, in which you've blown away the outer layers of the star. In fact, that's kind of what's happened here. This is probably type 1-2 supernova because that it blew away most of its outer layers. Now, if it blew away all the outer layers, it would have been a type 1C or type 1B supernova. But it didn't blow away that much, so there's still a little bit of hydrogen left. And what happened is that as the hydrogen was expanding away, that gave you those rings that you saw. So it was being pushed away. There's a little bit left. So when the supernova happened, the hydrogen there was, in fact, showing up in the spectrum, but the inner part of the star was moving fast and the outer part and overtook it, and so that masked the hydrogen. As the inner part overtook the thinner outer part, that's when it kind of brightened up a little bit. So that's that little bump in the light curve. And so that's the type of star here that's probably doing this. So this probably is something like that's between a type 2 and a type 1 C supernova. So again, type 1, 2. So this is a different type of. And so here's a little animated GIF right here that shows as the dates are passing down here, you notice that more and more of that ring starts brightening up as the gases start hitting it. And that's kind of what it looked like in 2003. In X-rays, you can see the entire ring is glowing because it's very highly energized. Well, duh, of course it's highly energized. It just blew up a star in the middle of it. Okay. So again, kind of another pretty view of this. Question, what about any planets? Planets aren't going to survive. There's no way. I mean, the supernova is so powerful, it's going to blow away any planet. If you were on a planet orbiting the star, then the planet would be completely obliterated. You would have the light would incinerate the planet, and the shock wave would blow it to smithereens. And so no planet is going to survive. And all that's going to be left is an expanding cloud of gas where the star used to be. And that gives you the supernova remnant. Well, closest type 1 supernova in 42 years, just kind of want to point this out, was actually discovered in a undergraduate class. And this was just a few years ago, 2014, that you had a college class. This was an upper division college class, and so one of the projects was they were supposed to use their own telescope to collect data for a project. And so the first of the semester, they were learning to use the telescope, and they looked at a galaxy M82, and turns out that they discovered a supernova during the lab where they were learning how to use the telescope. And so that just kind of an interesting little footnote.